I want to thank you all for joining us today for the webinar. Title is A Tale of Two Buildings, Balancing the Building Envelope and Comfort in a Multi-Use Athletic Facility. And the presentation today is by the Texas Section Forensic Group. I would like to thank the branches for hosting viewing sites all across Texas. As the State Association for Civil Engineers, we are happy to provide this service to the engineering community. If you are not a member of ASCE or the Texas section, I invite you to become a member so that you can benefit from being part of this professional association. I am pleased to introduce our speaker for today's training, Jesse Aguilar. Jesse is the chair of the ASCE Texas Forensic Group. He is a senior associate, Facilities Department Manager 3 at Terracon. Mr. Aguilar is responsible for overseeing and promoting the facilities engineering practice in San Antonio and surrounding areas. This includes coordinating efforts of staff, other service lines, and technical experts to ensure that all services are responsive to the client's needs, focusing on being on time, following the scope, and meeting the project requirements within budget. He provides technical direction and training to professional staff to enhance their individual capabilities, to advance the promotion along the career paths, and provide assistance in promoting other services and projects whenever possible. His responsibilities include ensuring that the department projects feature quality construction produced on schedule and within budget. His forte is in details surrounding facility assessments, preparation, design and review of plans, specifications, reports, and the cost and quantity estimates for commercial, residential, and educational projects. With 20 years of experience in forensic and facilities engineering services, Mr. Aguilar's specializations include forensic engineering, building enclosure consulting, foundation movement studies, property condition assessment, facility condition assessment, vibration monitoring, building air tightness testing, and floor slab moisture consulting. So with the introduction, I hope everybody is ready to enjoy Mr. Aguilar's presentation and ask him questions. Jesse, yours now.
Great. Thank you, Russell. Thank you, Mike. Good afternoon, everybody. It's a pleasure to be here with y'all today. Appreciate you listening in on this webinar, and appreciate Russell inviting us to present and represent the Texas Section Forensics Group. Want to start off a little bit about talking about safety. Coming from Terracon, we're very safety conscious, especially these days with the speed of construction. We always start our presentations and meetings with what we call an incident and injury-free moment, or a safety moment. Diagnostic projects, throughout my career, and for those of you that have been involved with them, they have a lot of risk involved with the field work. This particular project, you're going to see where we're working at heights, on roofs, ladders, lifts. We were using hand tools and testing equipment. You're working around some sharp objects where portions of the structures of the building elements have sharp edges, corroded edges. We're exposed to insulation, pool chemicals, and pinch points. And so there was a lot of things that could have really been a risk and injured somebody in the site, and especially working around an active natatorium facility, which we're going to see here shortly. And a lot of potential slip and fall hazards. So, the plan for us was to, have a kickoff meeting with all of the individuals involved on our team, the owner, any subcontractors who are on site, recognize the risks, and develop a safety plan with proper PPE, making sure that the individuals that were going to operate equipment were trained and certified, so we could send everybody home safe and execute the project with minimal impact to the owner and their operations. So our objectives today, we're going to look at this multi-use athletic facility that Terracon has been helping the Alamo colleges in evaluating deterioration and deferred maintenance issues. We're going to look at the assessment methods that were used to perform the diagnosis and the causes and correlations of the facilities and where we were seeing the failures. And then we're going to review the recommendations and corrective actions that we provided to the college that we thought would best help them to restore the functionality of this facility and ensure its performance for the long term. So a little background on our project. This facility is located on the Palo Alto campus of Alamo Colleges. For those of you who aren't aware, Alamo Colleges here in San Antonio is a local college institution. There's, I believe, 6 campuses here, one up in Kerrville, and they've been around forever. And Palo Alto came online, I think, about 1985. And then 1981, they constructed this recreation facility, athletic multi-use facility. The great thing about it is where it's at on the southwest side of San Antonio, they don't have a lot of opportunities, athletic facilities like this. So this was going to be a really nice gem for that part of town that was kind of underserved, didn't have a city facilities anywhere near this capacity. And the closest thing you would probably find was going to be at the old former Kelly Air Force Base. But essentially what we had was one building that included a Olympics-sized pool within the natatorium, a central wing that kind of separated the natatorium from the gymnasium. And that included classrooms, strength training rooms, storage facilities. That part of it was a 2-story building, and really between that section and the natatorium, you're going to see it was very critical how those 2 portions of the building operated. Overall, it's about 92,000 square feet total for this particular structure, and it served about 8,000 students. It's probably a little bit more now, but also, again, you know, this facility was also open to the public and you know, served a much greater portion of the community. The development of this project was a shared effort between Alamo Colleges and the city of San Antonio. You know, both of them contributed funds to operate and also to build it. And again, you know, this meant a lot for that part. It still means a lot for that part of town. The exterior wall, essentially, it's a single width CMU block. If you're thinking about it from the inside out, you got a bituminous damp proofing on the outer face of the CMU, then a 2-inch polyiso board, followed by an air cavity, and then the exterior masonry was essentially just a veneer. And if you'll notice the lower right-hand photograph, you see these smeared joints. That was kind of an architectural feature that's throughout the entire campus. So that's not so much a problem as much as it's an aesthetic. But where you notice the arrows, those are also moisture stains that we started seeing during our first site visit out there back in 2009, and you'll see a little bit more of these telltale signs. You have a standing seam metal roof over insulation board, gutters and downspouts, conventional aluminum framed windows and louvers in areas, you know, some areas of the natatorium, but mostly on the other side of the facility. Elastomeric sealant joints, very typical. Mechanical cooling and heating. The central wing has chilled water, hot water supply from the central campus physical plant. 2001, there was some renovations for direct expansion cooling, dehumidification for the natatorium in particular. And again, that's about 10 years into after construction. One of the things that we've come to learn with all our clients, but especially the public ones, is that there are constraints. They struggle a lot with deferred maintenance. Budgets are hard to fulfill. You have needs across the board, and a lot of times the facilities folks are really having to fight to make sure that they can get their fair stake in maintaining the facilities, and a lot of times that's not always so successful. In particular for Alamo colleges, they were experiencing a tremendous boom in the 90s. They were building other campuses, so it was hard to really shine a light on getting appropriate funding for maintenance throughout the 90s going into the 2000s. Essentially, they were very dependent on the passing of bonds, which the good thing for them is the community in San Antonio is very supportive, but then again, dividing up that money and putting it where it needs to go, that sometimes can be a challenge. And considering that this project was, the operation is funded both by the city and the college, you have multiple stakeholders there, and the city, would also have to recognize that the needs of this facility, and the college would have to engage them proactively to get them to come to the table and put some funds toward the maintenance program. One thing we came to find out that they were also struggling with was just the attrition of properly trained maintenance technicians, experienced technicians that knew how to run these facilities. So about 2009, we got a call from the college, and Terracon has had an IDIQ contract and has been on contract to provide general engineering services, ranging everything from geotechnical, forensic diagnostic, to building enclosure. So college reached out to us and said, we're really struggling maintaining environmental conditions within the facility, particularly the natatorium. So he said, well, we'd be happy to come in and assist. Let's take a look at what we can help. The conditioning of spaces was a struggle, condensation on surfaces, and you can kind of see there on these photographs. The upper one shows some exterior doors, and essentially those doors are wet. I mean, the picture, because I had to crop it a little bit, may be hard to see, but it's not just a sheen, that's actually a condensation on the door surfaces. And the closures as well above. And you see these stainless steel panels, these control panels have also now developed rust on the surfaces, and we really see that throughout. They told us they started experiencing water staining, microbial growth on ceiling tiles, and we're going to see a little bit of that here in the near future. And so again, 2009, we came on board to start doing an assessment. When we first came into the natatorium, and I can't tell you because I wasn't exactly there at the time, but talking to some of our mechanical folks that were engaged at the beginning, they said this was like walking into a sauna. I mean, you had a cloud over the pool, and they said, how long have you guys been kind of struggling with this? And the maintenance folks were like, well, I haven't been here that long, so it's fairly new to me, just a couple of months. So we had to kind of really start digging and finding out when did this actually start, and it all seemed to have been occurring at least 4 years before, when they really started having control issues. Photograph on the right shows microbial growth on ceiling tiles, and again, so you have the natatorium on the south side of the building, followed by the 2-story classroom facility, and then on the north side of that is the gymnasium. So between the natatorium and the classrooms, you see the classroom now is having conditioning issues. So we decided to go ahead and do an initial HVAC assessment to get an idea what the conditions of the systems were, how were they performing, and started that with looking at the natatorium. It's on a DX system, dehumidification units as part of the heating water supply from the central plant. Electronic controls used to control reheat and relative humidity. They did use heat recovery from the pool for boilers to use that as part of the dehumidification process. And again, a lot of stainless steel throughout this facility. You're going to see where that really becomes a bigger issue. They informed us that the systems were continuously operating, and in order to keep the conditions to where they could operate and use the natatorium, and that's not supposed to be typical for natatorium facilities. You know, the RH level, relative humidity, when the system would shut down, would just spike, and you couldn't have anybody in the facility. It was just too uncomfortable. Now, ideally, from looking at the plans and specifications, it was designed as a neutral air pressure facility, but somewhere along the line, something went wrong. We looked at the central wing. Again, you have chilled water heating, multi-zone air handlers, ducted outside air, conventional high velocity insulated ductwork, pretty typical stuff for what you would see for an institutional facility. But again, similar to the natatorium, the systems were constantly on. They essentially couldn't shut them off because they knew they were struggling to maintain comfort level, temperature, relative humidity, and so we started recognizing there was a battle going on between the natatorium and the central wing located right adjacent to it. The photograph on the left is part of one of the strength conditioning rooms that they had, and these were relatively small rooms on the east and west sides of the second floor of the central wing, but this is really where we started seeing issues showing up with the conditioning of the spaces. You know, without even getting up close and touching that wall, you can see you've got moisture issues inside of it. And so we pretty much said, yeah, Chewy, I've got a bad feeling about this one. Going a little farther north, we looked at the gymnasium, chilled water again. Overall, this looked considerably well. The relative humidity conditions were nowhere near what we were experiencing in the other spaces, and essentially they had much less concern with this part of the facility. So once we went through and did our interviews with the maintenance personnel, looked at the construction documents, we went ahead and started our field investigation, started poking and prodding and seeing how things are operating, what's functioning, what isn't. We use diagnostic tools such as manometers to check pressures, use relative humidity data loggers to get RH and temperature variable values in spaces, and then we used infrared thermography. And so essentially what you're seeing on the right hand side of that image is an IR scan of the exterior. It's the interior wall that separates the west side weight training room from the natatorium. And so the blue area is showing us concentration of moisture that we've got in the wall. So our findings basically show that the air volume for the natatorium was within 10% of design, which, considering the age, was pretty good indicator. It looked like it was performing well. But we did find that one of the dehumidification units was not operational, and apparently they had a control panel that failed and hadn't gotten repaired or replaced, and this was really making the other unit work extra hard, and essentially they were struggling to try to keep relative humidity conditions within operative levels, and that's why the equipment could never shut off. You know, generally the RH at the time when it was July of, we ranged between 77 degrees Fahrenheit, and we had an RH of 78. So right there, right off the bat, knowing what ASHRAE guidelines call for in relative humidity to be between 50 and 60, we were well outside of the comfort zone. ASHRAE recommends RH to be between 50 and 60 just so that folks feel comfortable when they're in the pool, and you know, we were definitely almost 20% above that. We also noticed that there was positive pressure of the natatorium relative to the outside spaces in the central wing. And so as that system was operating, it was also trying to push air out and into other spaces. And if the building was constructed by itself, it wouldn't be such a problem. It'd be an efficiency issue with the building envelope. But we definitely started suspecting that we were seeing air movement into the central wing. Looking at the units themselves, there was a lot of salt and corrosion on the DX, the frames, the lamination of steel was observed, and so we knew that some of these elements, even just the structural elements, were going to have to be replaced. Heavy corrosion on the stainless steel ductwork. I mean, we saw this throughout. Handrails, everything up to the dive platforms where you had the handrails were being affected. The center wing, there again, you know, relative humidity was about 45%. So that was in a good range for an occupied space. It wasn't the systems were operating more efficiently, and again, these systems were independent of the natatorium, so we didn't see a whole lot of issues there. But we did measure a negative air pressure. So as the natatorium was putting air out, the center wing was pulling air in, and basically taking on this moisture-laden air from the natatorium and pulling it in through wall cavities that we suspected, but we hadn't seen yet because we hadn't looked above the suspended ceiling. But you're going to see some of those observations here shortly. They did have issues with operational performance of dampers that were closed or wouldn't function because they were pneumatic systems and were essentially reaching the end of their service life. So those were items that we could easily pick off and say, you know, you need to get these systems replaced because they're not operating functionally anymore, and they are at the end of their service life. Gymnasiums performing probably the best out of all of them. You had about 72 degrees and 47% relative humidity. When we walked in there, it was very comfortable. Didn't feel a whole lot of issues. Overall, what you would see in the basketball courts, the framing, exposed framing at the ceiling line, you saw some paint peeling, but nothing to get too excited about. So we felt that the controls were probably operating a little bit better there, even though there were some issues with building pressure fluctuations where it would be positive, but then could easily be negative depending on when the systems were turned on and off. It's probably more associated with building envelope and the sealing of the building envelope since the time of construction. So here again, these systems were essentially going from good, fair, poor, with the gym being the better one and the natatorium being the one in poorest condition. So as we were wrapping up the HVAC assessment, we could tell that the air changes in the natatorium were insufficient. A lot of corrosion, air handling components, and essentially it was time to replace the DX cooling and dehumidifiers at the earliest opportunity. A lot of the stainless steel was affected, and we recommended that for replacement as well. We'll see later on where the college ended up coming back with a Hvac ductwork system, which is performing very well now, considering where it came, you know, where they started with. Air balancing was recommended to improve the air exchanges, but also to try to take that positive pressure out. But then also looking at the center wing, we were recommending for them to increase the pressure there so we could try to push back on some of that moisture-laden air coming in from the natatorium. One thing that we didn't really get into very much was that, you know, there was chemical storage in the boilers located just outside of the natatorium, and they had some air movement issues. So we recommended some improvements there to provide better ventilation, because they were getting some air movement coming in, and you could start picking up some of the fumes from the chemicals. Again, air balancing, even though the gymnasium didn't need it as much, since they were already going to do it for the natatorium and the center wing, we recommended it for the gymnasium as well, just to improve the positive pressure in these spaces for the long term, as they would be contending with anything that was going on in the natatorium. Essentially, the air handlers for the center wing would need to be replaced. Again, a lot of corrosion that we saw there, and then the balancing of the systems. This is really getting into more of the deferred maintenance side of the house, where they just didn't have the resources or the funding to put these either through the in-house maintenance staff or through a service provider to really take care of these systems. So once we got to the table and we shared our findings, they said, well, great guys, we appreciate it. We got a plan now. You gave us a roadmap on where we got to go next. They said, but what about the damage that's already been done? And this is where we started learning a little bit more about some of the things that were happening with the roof, with framing items in the roof, and more so going on above the ceiling that we hadn't been shown as of yet. So we told them, well, you know, given the age of the facility, you're probably due for a building envelope assessment. So we sent a team out to go and evaluate how the envelope was performing, how the exterior walls, the roof were aging, if we were identifying any conditions of failures or items that just were due for replacement because of where they were in their life cycle. We noticed gaps in some of the joints, you know, loose masonry veneer on the exterior. And again, this is really just a veneer that's been mortared onto the wall system. And so with time, some of these elements were starting to separate. We observed that fluorescence at window sills and the beams. And I think a lot of that was also being driven by the positive pressure that was being experienced in the natatorium. But then you had little construction issues like missing weeps or obstructed weep openings that needed to get addressed and corrected. We did notice some mold growth on some of the exterior walls, particularly behind downspouts, because the downspouts were leaking and they were in dark areas where mold could grow. And so those were kind of like the low-hanging fruit that we could identify them to kind of start working to improve the condition and the appearance of the facility. But there were also grade issues where at grade they had negative drainage directed back toward the building. Some areas around doors, water was getting inside. But then some areas we also noticed, because of the positive pressure and the condensation, that water was coming out. For example, those doors that I showed in one of the previous slides, there was essentially a puddle in the middle of summer, and it was because the building was essentially weeping, and due to all the condensation. So here's a couple photographs of our building envelope assessment. You know, we got up on the lift, started looking at the masonry, and we said, well, yeah, we could, you know, it's probably about time that some of the stuff got replaced. Ceilings were very worn and weathered and due for replacement. We started noticing more of the water staining at the exterior walls. Efflorescence around windows were a big item, and then also just the ceiling around the windows and the deterioration of that was really something to get addressed. Then we also noticed the condensation building up between the double pane windows, and that really was kind of speaking more to the climate issues that they were having and humidity issues inside the natatorium. Again, some photographs of failed joints and poor drainage, where some of the flat work has been sloped back toward the building. So as we dug a little deeper, we performed some exterior wall openings so we could see what we couldn't see before, and look at the damp proofing, look at the insulation board and the cavity wall, and make sure that the through wall flashing was functional. And essentially what we found was the polyiso board did not go the full height of the interior wall. And so there was areas where you could develop moisture issues inside the wall cavity. End dams were missing from the window sills in the corners, and through wall flashings were missing flashing membranes at some of the jambs. And in some areas, just through wall flashing was not complete, or it was missing, or didn't go all the way to the corners of the wall. And so that was really more of a workmanship issue that ideally should have been performed during or picked up during construction, but it wasn't. We got on the roof. We, based on the information they gave us, they showed us that, yeah, they've got a lot of leaks, and really couldn't understand, because typically with a good performing standing seam metal roof, you shouldn't have a whole lot of leak issues if you're maintaining it right. But what we did notice that a lot of the sealants around the fasteners were deteriorated. And so as we started doing some pull tests on the fasteners, we noticed that they were failing, rather quickly. In some cases, under very low loads, they were pulling out directly. And as you see that one picture on the bottom of the slide, there's section loss on that fastener. So we're really, kind of pointing more to the condition within the natatorium, because this is primarily where we were seeing the roof leaks, and how that moisture-laden air was now affecting other parts of the structures, where it was now getting past the insulation and affecting the fasteners. Again, weathered sealants, a lot of this stuff was kind of deferred maintenance. Insufficient step flashing, that should have been addressed at the time of construction. Essentially, the step flashing was relatively low. Water was getting behind it, and so they just didn't have a good seal against the exterior wall, especially with that split face veneer. It makes it very hard to get a flush finish and a tight seal against it. So as we got back inside the building, and after looking at the fasteners, we said, well, we need to tie these ends together and figure out what's going on with that roof deck. So we decided to dig a little bit deeper, and kind of working our way from the east and west sides where those weight training rooms were. Started looking at the framing and uncovering some spaces. We removed some of the fireproofing so we could see the deck and the beams, and expose what we saw is a lot of corrosion that started to develop in the purlins and the beams. And the other part of it was that wall, and again, it's a wall cavity between the two exterior walls of the natatorium and the classroom building. But essentially, it was almost like an open air plenum. Air could easily move from the natatorium through the plenum and then get pulled into the classroom plenum, where it would start condensing on surfaces, everything from the structural steel to any stainless they had for equipment. Everything was starting to rust over. And so this picture here on the right shows you where this beam running within the cavity wall has already started to experience pitting on its surfaces. And this usually got worse toward the ends where the weight training rooms were, and I'll show you that in a minute. So if you remember this photograph we showed a little bit earlier on the west training room, here it is with infrared, and you see just a concentration of moisture inside the wall cavity. So right off the bat, we know we've got significant issues, and so we decided to start poking our heads above the ceiling, seeing where's this water coming from. Is it more isolated to actual roof leaks, or is it really air movement that's contributing to this? And so as you look at the slope roof deck, a lot of corrosion between the flutes and then coming into these beams that intersect the wall. And so essentially these beams carry across into the roof system of the natatorium, and they're not sealed. They're open from both ends. So air, you could put your hand up against, you can just feel the air getting pulled through. And if you look at this purlin here on the right-hand side, all these little droplets of just condensation that have been there, for a very long time. And you would expect to see that the shape or the condition of this purlin would look more like this beam, but it looks like you just dipped this thing in water and submerged it for a while, and you got a lot of pitting that's starting to occur. So this would really ramp things up to where the consulting structural engineer, we pulled them in and started talking about, okay, what's the extent of degradation? We definitely observed section loss, and where are we going from here? Because anything we did to try to replace or repair these elements would require, essentially removing part of the roof and shutting these classroom spaces down for a period of time. So essentially, coming out of the envelope assessment, we said, look, you've got deferred maintenance issues. There's cracking, there's joints that need to get replaced, loose veneer. That's all the low-hanging fruit. The real issue at hand is working through the mechanical assessment and getting the conditions within the natatorium under control, getting the humidity under control, dehumidifying it, putting it into more of a negative pressure condition, but also working with the center wing to put positive pressure into that, while at the same time looking at what's left in these elements, and if they've been structurally compromised, that now maybe the roof system is not going to perform, and it's been compromised in the roof decking as well. And again, a lot of this is going back to the deferred maintenance issues with respect to the enclosures, replacing damaged ridge caps and openings throughout the roof panels. So, if we think about where they need to go next, and this was, our initial HVAC assessment was in 2009. We came back and did the initial envelope assessment in 2011. Fast forward to 2015, after a bond election passed, they were able to get a CM at risk engaged and start prioritizing some of these issues so that they could start putting them up for repair. And so with the CMAR, with the architect of record, Terracon's involvement, the structural engineer, the mechanical engineer's involvement, we prioritized what we could leverage to do now or at that time to extend the service life of the facility, and really triage what was important to maintain the structure, improve the health of the structure, and then also start looking at programming for a true preventive maintenance plan to address some of these other items. And so coming off of that, we identified areas of the repairs needed to get addressed, replacing the dehumidification systems at the natatorium, and one of the condensers that was failing prematurely. The option was brought up to bring in fabric ductwork and replace the stainless steel, and they did that. They also brought in some large fans to help circulate the air and try to get a lot of that moisture-laden air moving, so it just didn't hover and concentrate up at the ceiling level or was getting pulled into the center space. And then we also recommended doing a retro commissioning plan just to get somebody to actually do functional performance and go through all of these systems and make sure that they're working efficiently, that they're not short cycling, and we just don't have another sleeping dog out there that's going to come back to bite them once everybody steps away from the project. And so right now what we're looking at is 2018. They've put some money into the program with the replacement of the dehumidifiers, but structurally we've gone back out with the structural engineer and looked at the conditions. Again, no repairs have been made up to this point. but the plans are in development so that with this most recent bond program, they're going to be able to create some projects to start replacing the roof and the structural elements out at the edges. But what we're looking at here is some of the new systems that were put in for the DX units, for the natatorium, and everything that we're talking with the maintenance folks are saying these are performing well. The maintenance people have gotten training, and they're very comfortable with the systems. They're user friendly, and they're having a lot better performance and maintenance of relative humidity. This picture here on the right, that is actually a fabric duct. So when the system shuts down, this duct will essentially kind of collapse, and then once it system comes back on, it kind of inflates. But very little steel components in this, metal components. It just much more functional, just works very well for this type of facility. A little further down, they do have some fans that were coming in during this last site visit that we made, and these should now be operational. So they're improving the performance there of the natatorium. And while we were there, we just did a look-see to see where things were with respect to some of the framing elements. The good thing is that we didn't see the wetness that we saw before. So with some dehumidification that they've done in some of the spaces within individual units, they were able to start pulling moisture out, drying things off. But from a performance standpoint, these elements aren't getting any better. And you can see now where this bolt and nut connections, the nut is essentially starting to experience section loss, and in other parts of the framing elements, you've got section loss, where this is essentially the roof deck in one of the strength training rooms. So how much of this needs to be replaced? We're working with the structural engineer right now, doing some diagnostic testing, non-destructive testing to determine section loss. But everybody's in agreement that this roof deck needs to go. It's the challenge is going to be some of these larger wide flange elements, and how far do they need to be replaced, or even do they? And so that's part of what we're trying to find out with the testing is, do we have enough section left that we can rely on these elements, or is the repair going to have to be a lot more invasive? So our takeaways, essentially, the long-term performance of any facility, it's critical for the HVAC systems to be working as designed, especially with natatoriums. I had been involved with one previous natatorium project, wasn't anywhere near the level of deterioration or climate control issues as this one, and with that shared wall, that cavity wall not being sealed, it just ran the gambit of what could be going on in the adjacent spaces. And the part that we're still trying to figure out is how much more do we really need to look at? Is the area really just going to lay within those ceiling spaces above the strength training rooms? We're looking at trying to do some more invasive openings in the wall and above the ceiling line, so we can get a better feel for what's going on within the walls, and if the repair is going to warrant expanding the scope just beyond those particular spaces. And really look, in kind of titling this presentation, A Tale of Two Buildings, it was one building, but really should have been designed as if it was two, with a positive air barrier put between the natatorium and the center space. Looking at the plans, there were details that showed how that wall should have been sealed, but the openings, the cavity, it just tells you that just did not get done, and maybe it was just a hard too tough of an issue for the contractors at the time, but so much more critical now to the long-term performance throughout this facility and how it gets used going forward. And a lot of this drove the premature failure of the systems, especially with the DX units. You know, having to replace one, you know, I would think that by now, talking to our mechanical folks, depending on the efficiency, you know, 20 years, 25, you know, you could probably expect that. But you know, were these trending along that? They were close, but the other issue is the colleges didn't have a plan to phase them out before things started getting critical and impacting the use of the facility. And the other issue was just the preventive maintenance part of it. You know, the PM needs to be the program needs to be identifying issues early on and putting them in a schedule for replacement or service so that you get ahead of the game. You know, in a lot of the condition assessments we do, just because a system is at its end of its useful life based on its age doesn't mean it's not functional. You can do a lot with preventive maintenance and extend the service life. But what we saw here is that with a lot of these systems, it just wasn't happening, and it probably short-circuited the service life of a lot of these systems that were ongoing or operating throughout the building. The other part of it is just the stakeholders, everybody from the maintenance folks to the folks at the city that provide the funding. They need to be aware of where the how this facility is performing and what is it doing, so that the mission of the facility can be realized, and everybody knows that if we have skin in the game, we need to be contributing to finding the fixes and being proactive about them and not letting them stay on the back burner to where one day we have to shut the building down because it's not safe to be inside of it anymore. And so I love this photograph. I wish I had it in color, but essentially as we were walking through, we just said, you know, with the manometers and everything we got, let's just, you know, see if this facility really is under positive air pressure. So we ran over to the restroom, you know, got some tissue paper, and sure enough, that is the doorway that leads from the natatorium into the two-story center wing of the building. And you know, with that, it just visualizes the air movement issues happening throughout. And as you can imagine, what's going on within the space, and then what's kind of getting pushed in through open joints and cavities above the ceiling line where we saw most of the deterioration. It's you know, it really makes you think about how these facilities perform. So that kind of wraps it up for my presentation. Appreciate again everybody staying on, and I guess we can start looking at the questions, Russell, and seeing where things are. Let me go ahead and turn this back over to you so we can start engaging folks.
Sure. Let's see here. So if you have any questions, please type them into the chat box, and we will address them as time allows. If not, if we don't get to the question, we will still forward it on to Jesse and try to get a response back to you. Let's see, what do we have here? What are some of the challenges with accessing the building that you had to address in order to perform the assessment?
Yeah, one of the problems we had is that, you know, even though the initial study was performed in the summertime, we still had classes ongoing. Some of the site visits we had to perform after hours. But one of the biggest issues was when we were doing our exterior wall assessment and getting up to height so we could look at the structure, look at the envelope. You know, there was a picture in there, and you if you weren't really paying attention, you wouldn't notice it. But there's a lift that we managed to get into the natatorium. It was an articulating boom lift, and our operator was very skilled in maneuvering that in there, but it worked, and it was very beneficial for us to be able to see the cavity wall from the natatorium side, and then kind of start chasing where the air infiltration was occurring and the air movement was occurring, and then also just kind of being able to diagnose where certain elements were and how the coatings were performing. And so, you know, that was the biggest challenge, is just working around, you know, a occupied facility, and then getting to the spaces that we needed to get to. That you know, and we see that with a lot of projects, but with this one, it was just a little extra special.
It looked like you had to do some cutting into areas or removal, as you said, of the fire protection. How is that? How big of an area do you have to open up to get in to see? And then how does I guess the contractual obligations for repair go to that?
Yeah, in that case, we had a third-party contractor that was working under Terracon to help remove the materials, and we basically gave the client an option we could repair them in place with what we would call temporary repairs, because they weren't permanent, since a lot of the elements were still exposed, and where we removed some of the fireproofing, the substrate, the roof decking was just coming apart. So essentially we just said, well, we've seen enough there. Let's just coat that with some corrosion inhibiting paint where we can. But in some areas, as we were exposing things and we brought the facilities folks up with us, you know, they were kind of saying, well, you know, if we can coat it, great. If we can't, well, it's probably deteriorating about the same rate as everything else up there. So part of it also was to leave some of it exposed so we could see how it was going to perform after repairs were made. We would have liked to have seen the dehumidifiers go online sooner, but again, you know, with educational institutions, some of these things, they're just labored with contracting and you know, funding issues that they just can't move fast enough. It's hard for them, as much as they want to get these facilities back online, but they've got to jump through a lot of hoops, and so time passes. And so that's why from periodically we would make some site visits at their request, just to say, okay, you know, we're not going to get it in this summer for the program. Can you come out and tell us, you know, how is it performing? Do we need to do something, or do we just need to elevate it to an emergency level? So, you know, we try to supplement our assessments with those additional site visits, so they could at least have some level of comfort or direction on where to go with those exposed elements.
Okay. In one image, you had an infrared thermographic picture for temperature. Another image, you showed moisture in a CMU wall. Is this done with the same equipment?
Yes. Yeah. So we've got a couple, and you know, now the market, you know, fast forward a couple of years more, the market's just flooded with different types of IR cameras, and you've got several different big name manufacturers and vendors out there. But essentially, yes, with that camera, I believe it was the same one, and so, you know, you can change temperature gradients, you can you know, show temperature, and really what we were showing on the screen were all temperature. The relative humidity, that's probably was done with a probe, a data logger that we left in place, and then once we took the image, we went in and inputted it, so you would have that information if the RH is on there. That's how we measured it. But really what we're looking for is the temperature variations, and they would show anomalies of moisture concentrated in the walls or the insulation with the IR camera.
Okay. Was the original design team consulted prior to or during your assessment?
Yes, and again, that initial assessment I wasn't involved with, but talking to some of our folks that were, the project architect was brought back in, and they were, we weren't doing design work. We were doing diagnostic forensic work to help show them where they needed to go with the next steps. And so the architect was on board assisting, and so was the mechanical. I can't recall if the mechanical engineering consultant was the original, or if it was somebody that was brought in under contract similar to us. I think it may have been somebody who was brought in under an IDIQ contract to help support the design effort. But you did have stakeholders there. I don't believe the contractor was engaged, though. I think the college felt like they're just going to take care of this, and if they needed to get somebody, they were going to go through a CM at risk contractor to get them engaged. But I don't believe the original contractor was engaged.
Okay. What changes has the college made to better manage the facility, and have they made the repairs to the exterior walls and ceilings and flashings as recommended?
So there is a campaign to get the envelope tightened up. It's right now the focus is on climate control and managing that, and then the next phase is going to be looking at the structures, the elements that have been deteriorated and corroded in the roof decking and the framing elements. And after that, once they've replaced that, they're looking at doing more of a comprehensive exterior wall repair. And again, what we saw was probably typical of a lot of buildings of that age, but the focus needed to be on just getting the climate under control so that you could start drying things out and creating projects out of that that ultimately would lead to addressing the deferred maintenance with respect to the envelope. But second, critical to the climate was getting the roof replaced. And as far as I can recall, that they were going to move forward with that, but once we started talking about the potential corrosion and extended corrosion, they pulled back on the roof replacement, and they've gone back to get more funding so that they can get more of the framing elements replaced under that same package.
All right, Jesse, thank you so much. This has been a great presentation. Thank you again for participating in today's ASCE